So, hi everyone. There's something that I always say about software engineering, that you can never read a book, watch a video, take a course, and then be confident enough that you can implement something that real users will use. And I will keep repeating it. What you learn in the textbook is just like a foundation to give you like the mental picture of the concept, so that you have an idea when we talk about load balancing, when we talk about replication, what does it mean? But that doesn't mean that that's enough for you to go implement. And there's a scenario I'm sharing here, just like something that anyone else can go through. So before you go through what I have gone through, this should serve as a lesson for you. Learning it, reading it is good enough. You're laying the foundation of understanding, and then you can go ahead and implement. Now, I've been building MetaDev. MetaDev is like the career OS for developers, and also focused on AI education and AI capabilities. And part of MetaDev, we have a module called Arena. So Arena is a gamified experience for developers, especially designed for team leads, events, and meetups. So assuming you are at an event, and then you're hosting about a particular theme or topic, let's say AI agents, or just talking about, anything, databases or LLMs or machine learning. And then, you give a speech, and after the speech, maybe you want to gauge the experience, or you give a talk, and then after which you want to gauge the experience of those who attended. Now, that's where Arena comes in. Arena comes in, all it needs is just tell it your topic, then give a brief description of what you want to test your audience on, and then it will curate questions using AI, and then your attendees can join and play. Of course, it's very gamified, and then it's timed, which means like if you get it correct, you must answer very fast at the top. Otherwise, all of you will get it right, but one will be at the top, someone will be second in the list. Now, last Saturday, we were hosting an event on MongoDB, and for the first time, we were putting Iron to test. People have been using MetaDev, but we've never put Iron to test. And something strange happened. So in the event, we were more than 30 attendees, and when we spin up the game, I was actually leading the game. So users joined the game, and then we noticed that after the 15th player joined, the rest of the players were hitting 429 errors. And if you know 429 by now, is about rate limiting or throttling, which means I set my application to only accept 20 requests per minute. Okay. And then the problem comes in. You only have 15 users logged in. Even the 15 users, I don't think each user is already sending 20 requests per minute. And I'm like, even if it was to be that case, then at least all users should join in, and only then they should get 429 errors. Remember, this throttling is globally in the app. Now, we only managed to allow 15 users in the site, and I was actually worried, like, what is the problem? This is a problem that didn't surface when I was designing. So later on, when I was now doing the RCA, I sat down and then checked what was the problem. And trust me, no textbook, no video, no course was going to teach me this. I had to go and experience it, learn from it, and then rewire my application to support it. So I'm doing an RCA with you here now. Just watch the next video. Of course, in the same video, of course, the next part of this video, to understand how the problem surfaced, what was its root cause, and what was the solution to that problem. So go Codes, signing out. See you in the next video in the logs from the battlefield. Let's talk about throttling and rate limiting when building an application or designing your application. So we're going to talk about what we call throttling of requests, or what we call rate limiting in application. So right now I'm building on Nest.js, and then I'm using a Postgres database, and then of course my front end is Next.js. And just to show you like a quick demo of the application and how this video is inspired, this application is metadev.com. So basically, if you go to www.metadev.com, you get access to this application. This is Africa's Tech Pulse, application that I'm building as a career OS for developers. So here you can really like boost your skills or just use this as a launch pad. Now, in this application, we have something called Arena, a module called Arena. So let me just allow notifications, of course, to get live notifications. So let me sign into Arena here. So I will continue using GitHub, as that is my preferred login method. And then once I'm in, I'll show you what happens. What's the problem? Okay, just log in here using GitHub. So we are in here. Now, I wanted to take you direct to Arena, because from this Arena, this is where this video has been inspired. So you have Arena here. In Arena here, this is like a module that you can use if you're hosting events or you are a community lead, then you can use Arena tool to gamify your experience with your community members, which means you can use our AI tool to help you come up with questions and answers in the topic or theme that you're talking about. For example, in our last event for MongoDB User Group Nairobi, we were talking, or our theme was on AI agents, MCPs, LLMs, tool calling, memory integration. And that was the theme of the day. And during the first session, we did have like a gamified experience just to gauge the understanding of all those who attended. And right here, you can see like how the game was and all that. Now, this is a module which is real time because it is designed in a way that the faster you answer a question, the more points you get if you get it correctly, because it's a gamified experience. So each question has 60 seconds for you to answer, and it's multi-choice. So all of you can get it right, but the person who answers it quite fast will get more points, as you can see. For example, I wanted to show you something here. If you see at the first position, they have a stick of 8. Second position has a stick of 6, but third position has a stick of 8. But the second position has a stick of 6, but still managed to be on top of the person who has a stick of 8, which means that this person was able to answer quite fast compared to the third person who had a stick of 8. Now, this was the very first time that we were putting this model to test in a live environment. And during that process, I did learn something that textbook knowledge won't help me figure out during development. Some of these things you only understand or get to learn about them on a live application, getting the real feedback from the user. Okay, so what was the problem? So the event had more than 20 users, or let me say more than 30 users, attendees, let me say. So we had more than 30 attendees. I'll put it here. We had 30 plus attendees coming for this event. And my next Nest.js backend is designed to throttle requests at 20 requests per minute. So now I spin up the game and then I display the QR code for users to scan and join. And some were joining with the game code. Of course, I'll show you how people join. So for example, when you come back to Arena here, we have live now, which means this is a game that has been set up. And right from now moving forward, anyone can join. If I click on this, then you get either a QR code, which you can scan, and then you also get a game code if you can't scan. So you can either use a game code or the QR scanner to join the game. Now here's the problem. So people scan the code, some use the game code, but then some of the users are hit with a 429 error. So 429, if you know very well, 429 is too many requests. Error. So what it means is that the application is seeing like there are users that are sending more than 20 requests per minute. So I was there like wondering what is the problem. I don't think at this moment any user will send 20 requests per minute. Not possible. So at the end of the day, we only ended up having 15, as you can see from this history here. We only had 15 players who were able to join and play the game out of the more than 30 attendees. So later on, I came back to check. Now in my application, remember, like I mentioned earlier, I only had like an implementation of I'll only allow 20 requests per minute. Now, which rate limiting strategy was I using? So I was using the strategy where I limit based on IP address. Okay, so my limit, which is 20 requests per minute, was per IP address, which means if my server says the same IP address 20 times, then what happens? It will start throttling that IP. So that IP won't be able to make additional requests until that minute settles down. Now, my question or the problem I had during that event on the stage was like, this is not an error that I'd seen during development. Why is it surfacing now? Now, only for me to realize later that since we were in a conference room, let me show you. We're in a conference room, and this room, we were using a shared Wi-Fi. So this is our conference room where we were for the event. Let me just name it our conference room. And then now, remember, we are more than 30 here. So we have devices all over. We have devices. Everyone has a device connected to the Wi-Fi in this room. Now, since they're connected to a Wi-Fi in this room, which is a shared Wi-Fi, maybe through a router, then where my app is or my API is hosted and serving the requests, when we send requests or users are signing up, because the throttling limit I set was globally in the app, okay? So which means irrespective of the module that you are using in the application, you will always be a throttle at an aggregate of 20 requests per minute. Now, from textbook knowledge, what you'll expect is that maybe this is a different IP, different IP, different IP, different IP, because they are separate devices. That is true, very true. But the problem comes here. We are now in a room, shared room, and we are using shared Wi-Fi, which means all connections are routed through the router here. And because of the NAT translation, or what we call network address translation, my app, which is Nest.js here, this is Nest.js, Nest.js app, which I set to use IP address as strategy. Now we'll see all the incoming requests to be having one IP. And so the first user, let me say we have the first user logs in, perfect, successfully. Second user logs in. We have third user logging in correctly. We have fourth user logging in. Assuming the first user has logged in, let's say they have logged in, they have gone to Arena, or they are updated their profile. They have also tried to upload a profile picture. So logging in or signing up, verifying their email, profile picture, going to Arena, loading the game, joining the game. So this user alone will say they already sent 5 requests. 5 requests. This is still okay. And the same happens to user number 2, user number 3, user number 4. So we have 5 requests from user number 1, user number 2, user number 3, number 4, number 5. Okay. So how many users do we have who have logged in successfully and gone to Arena? We have 5 users. Okay. According to textbook knowledge, we expect that these are only 5 IP addresses. So then the rest of the 20 plus users should be able to log in with no problem. But that's not the case, because since they're logging in from the same Wi-Fi, 5 requests will be treated as same IP. So 5 requests times 4, we get 20 requests. So from the either fourth user going forward, let's say fourth user, they will start hitting the 429 error, this one here, the 429 errors, because one user already sending 5 requests, the other user already sending 5 requests in under a minute. That is why we were able to log in up to the 15th user, but from the 15th user, they were all getting 429 errors. This one here, too many requests. So after finding out during my, like finding their root cause during RCA, I realized that my strategy was not perfect for certain application where we will be real time, and for gamers or developers who will be joining in a conference or a meetup, this is not the best strategy to implement throttling. So the best strategy for us that I will have used before is, one, I will have used user ID, throttle using user ID. So if a single user ID sends more than 20 requests per minute, it is then that now we throttle them by showing them 49 errors and they can't make additional requests. The other strategy was to use maybe session ID. Session ID, for if you're logged in, remember sometimes you can have a session created for you in the database. So if we couldn't use user ID, we can use session ID. And the other alternative was to use the game session ID. For example, remember it's a real-time system, so we have a socket room here. So what we will have done otherwise is to come and also, instead of using user ID, session ID, or IP address, which is limited, we could have used also the game session ID. This way, the user ID is always unique, irrespective of the shared network. So our application is always going to see the user ID. And so if a user sends 20 requests within a minute, it's until then that now we'll throttle them. So this was suitable enough, or suitable for a situation where we are in a single room sharing the same network. And that's why we were able to only allow 15 users to log into the system. Otherwise, we wouldn't have faced this problem. The other method is to use session ID here. So session ID will also allow us, because when you log in, you have your own session ID. So that alone will be a unique identifier irrespective of the network or our method of connecting to the internet. And then lastly, the other method that I will have used is the game session ID. So remember, when you join Arena here, we give you a game session ID, which is unique to you, which means that will also serve as an efficient approach when designing Arena. So yeah, this is something that you can never learn in a textbook unless you implement and then put it to real test using real users. So had I not gone to a Wi-Fi environment or a room where we are sharing the network, this is something that I wouldn't have learned. And maybe one day when I'm in a big event or a critical session, my application will have failed terribly. I just thought it wise that I share this with you. So whoever is building a real-time system, depending on the use case, choose the appropriate throttling strategy. IP address is also good for some scenarios, but for a real-time system where we are in a shared room playing at the same time, it's probably the worst strategy. So you can opt for methods such as user ID, session ID, game session ID. Yeah, so these are just something that you can't read and implement. You won't know until you face this blocker. Otherwise, this is a lot from the battlefield, and I thought it was to share with you. Seco Codes signing out.